Okay, here's our topic. Here's our objective. HCl is a strong acid. Vinegar is a fairly weak acid in general. And we want to know why. Explain it. HCl dissociates and ionizes completely, whereas weak acids, weak bases don't. They set up equilibriums. And that's how it is what it is. It's good to know and memorize the strong acids and bases and so forth. And here are the ones that I want you to memorize. We all are familiar with hydrochloric and sulfuric and nitric acid. Some weak acids are these two, hydrofluoric, and this is vinegar, or also known as acetic acid. A weak base, a good example would be ammonia. And strong acids and bases are things like lithium hydroxide and strontium hydroxide, sodium hydroxide, potassium, any group 1 or 2 hydroxide, and the hydroxide is the OH group. Now, we're really just to go back to to recenter ourselves. When you look at these two solutions and you test their pH, you'll notice that vinegar is pretty is weak, and HCl is really strong. What are the atoms doing? What are the molecules doing to create that? Once again, this one is dissociating and ionizing. Sorry, dissolving and ionizing or dissociating, whereas vinegar sets up an equilibrium after it's been dissolved. So here we go. Now you'll notice here that HCl commits. It's not, this arrow means it's going one way, whereas here you've got the equilibrium. Okay. Now, if you wanted to look at a particular a drawing of the molecules, this is what a strong acid would look like. You're going to have everything is separated, all right? Everything is dissociated and high concentrations of hydronium. And then you'd have the anion. Sometimes these are even not even added; they drop out because they're often a spectator ion. But I included it there. Now, a weak acid, you'll notice that my hydronium concentration went down, so I made it less acidic, and I have some species that are not dissociated. And if this were a weak acid, I'd have this thing giving a hydrogen back to the anion and making this, and then this giving it to water and so forth. So it'd be constantly changing. All right. And a weak base is going to look very similar, except the one thing that's different is the OH typically with bases comes out of the molecule. Sometimes it'll be a little different, but you don't need water to make your hydroxide group. It just comes typically from the base itself. Sometimes it won't, but we'll get into that later. It's a different subject. And here is what a strong acid, excuse me, a strong base would look like. All right. So just to reiterate, HCl is really strong because it dissociates after it dissolved completely. Also, sometimes some people use the words ionize, whereas vinegar doesn't do that. It sets up an equilibrium, and vinegar is a weak acid. It doesn't dissociate completely, and it doesn't ionize completely. And it's the same thing for bases. A strong base, something like sodium hydroxide, all right, that's going to dissociate and ionize completely. Whereas a weak base, ammonia, sets up an equilibrium system.